Hi friends, welcome back to the channel. Today we're looking at Julius AI. So this is an AI that is supposed to be able to do stats and graphs and analysis for you. We've seen some very mixed and to some degree poor results out of the likes of ChatGPT and Gemini and Bard. With this, they are large language models, so we shouldn't necessarily be expecting them to be any good at maths and stats. Although eventually ChatGPT did have a maths module added, made it a little bit better, but still seemed to struggle on some fairly basic things. This is certainly the next step along where we have got something that is dedicated to these specific functions. So scrolling down on their homepage, we can see that they are doing charts and graphs. Got some examples there. Insights, doesn't really have much of an example. Advanced analysis, I'm a little bit concerned that they think that an analysis of variance is advanced analysis. This is really Stats 101. We'll test that out. Problem solving, so we will give that a bit of a test as well. And generating reports. So we'll focus on maybe giving it a maths problem or two to solve and then see how it goes with a bit of graphing and a bit of advanced analysis. When we log in, we can see that we have a really basic interface here. So just the chat window, I'm just on the free version. I'm going to start just in the chat by dumping in a normal distribution probability question. So I've tested this with ChatGPT, tested it first probably about 6 months ago, did okay, got the sums a little bit off but the methodology right. Tested it today, worked perfectly, so let's see how Julius does. Okay, first point goes to Julius. We can see that it has identified the normal distribution probability problem. It has given us the methodology saying, well, we can calculate a z-score, taking our figure minus the mean over the standard deviation, look that up on a normal table, and there's then given us the figure. And then it also here, if we click show code, gives us the Python code. So it's using code interpreter here. It's running things in Python. We can see that it is what we'd expect. Get the Z. It realizes that it needs to go 1 minus the CDF in order to get the upper tail, which is what we're asking about. And it gives us the correct value. So that is a pretty good start. Now what we're going to do is give it some data and test some of these graphing and other stats functions. Okay, so the data we're using is from the Australian Institute of Sport. It's a public data set, and we can see here that it's got information about athletes. It's got a range of different metrics. It's got gender, their sport. It's got a number of different figures from some blood tests, so red cell, white cell. What have we got? Hemoglobin, iron, we've got the BMI, body fat, we've got height and weight. And so this gives us just a nice little data set. In order to get what we see here, I just dragged the CSV file into the chat window. That's all that I did. And it was able to happily open it up, give me this preview. So I started with something really simple, just said, can you plot height against weight? As we can see, taller athletes tend to weigh more. After I did this, and it did it again in Python, gives the code for us to be able to see what it did. It then gives some suggestions here. Can we provide regression analysis, correlation? So these are quite reasonable, a little bit concerned about outliers. I think there's a tendency sometimes to get a bit carried away with removing things that are genuine bits of the data. But let's go, how does gender affect the relationship? Because that was actually going to be the next thing that I did, is get it to redraw this plot, but to color code gender. Instead, I'm going to take its suggestion. I'm going to see what it does. Okay, so that was unprompted. I just clicked on that button and I've been pausing it. Just takes a few seconds for it to process. It's actually pretty quick. And if we zoom in on our graph, we can see that it is now color-coded by gender. So it's given us the visualization. And so now maybe what we'll do is test it on a couple of stats. I don't think we'll get too fancy, but we can see so far that it's been taking the requests, turning it into something to do in Python, using Python to output the analysis, and it's been doing a really great job. Okay, so we're not going super fancy with this. So I've just asked it perform two-way ANOVA for weight using sport and sex. And I did not specify anything about post-hoc comparisons. I also didn't put anything about whether it should test interaction effects. So let's have a look and see what it does. So it did test it with an interaction effect. Didn't tell it to, but it started there, which is great. And then we can see that it is telling us sex has significant effect, sport has significant effect, interaction does not significantly affect weight. So that all looks pretty good. Again, it gives us these 4 different suggestions. So what might we want? So implications of the interaction between sex and sport. That's definitely something that is good to be including there, because if there was a significant interaction, that would definitely impact what we did next. But what we'll go with is, can you provide more details on significant effects? So let's click see what it gives us. Okay, so this one was a little bit disappointing. It took it a little bit too literally, just gave us the F stats out of the table we already had. I was hoping that would know that next step might be some post-hoc tests. I'm going to ask it directly to do that. Okay, so that started out pretty well. It started doing the 2K HSD for each of the 2 categorical variables, exactly what we want. We can see it then had a bit of a freak out in terms of trying to present this in a table, so it all got a bit messy there. Coming down though, it then did give reasonable summaries, so the summaries are right, just the presentation ended up being a bit of a mess. So that's an interesting one, might even flag that one with the developers. So we've done that, maybe we'll just ask something a bit more vague about just reporting what else it can find in this data set. Let's see if we give it something that's a fairly vague instruction that someone that's not particularly numerate might ask. What's it going to give us? Okay, so I guess didn't go as vague as I originally planned. So I've said, can you summarize this whole data set, and it should be analyze rather than analyzes. Analyze all of the relationships that help predict the weight of an athlete, include relevant graphs and tables. So we'll see what it does. It's made a mess of that comparison table again. Okay, so summary of the data set gave us a list of the different variables. It did actually expand out their names, even though I haven't told it that. So that's quite good. So sourcing that from somewhere. Other than that, it's just grabbed what I'd already done. So it hasn't done any other analysis. I don't know whether starting a new chat to request a report might have made a difference there, or whether to really get the best out of the reporting you need to do each of the pieces of analysis first. Ideally, that's what you should be doing. If we're doing a report, we would be doing each piece of analysis anyway. We can see that mess that it made. It didn't do any graphs, so it didn't quite follow what I asked for there. Okay, so this was my pretty ambitious request. Writing a report, asking for quite a lot of stuff here. Started off really well. I mean, one thing that does irritate me with Python is that when it does the summary, using the dot describe, it doesn't put in the names of the variables, which I find really aggravating. It'd be nice to get the percentages on the categorical ones as well. Then continue on the numeric. It ran through histograms for all of those, and then scatter plots for relationships to weight, then the correlation. And so this was all going really well. It started doing the regression, and then it had a little bit of a freak out, gave me a pop-up saying you're going to have to upgrade. So this is as far as we got. So it stopped at trying to do the regression. We can see that it started on the regression, but it didn't really give us the table. And I think this is me maybe being a little bit too greedy, trying to get everything all in there at once. Let's have a crack at a cluster analysis. Okay, so our cluster analysis, this I think was actually pretty impressive. It took 2 goes, and admittedly the first one, I mean, when we're doing a cluster analysis, there's different types we can do. There was a lot that I left really unknown here. It took the data set, stripped out the numeric. Probably need to check on what that missing is. I suspect that it's maybe reading a row that is blank, but then it decided it would go with this particular silhouette score method for determining the number of clusters. I just picked 6 a little bit arbitrarily. Normally with these they just tail out. It's a little bit weird to see it kind of peak back up, but nonetheless I said, okay, well, let's be a bit more specific. Kmeans cluster, 6 clusters, and interpret each cluster, and we can see that it did that. We've got the cluster means for each of the variables in there. Let's label them cluster 0 to 5 because Python likes indexing from 0. Messes with me a little bit as an R user, but that's fine. We'll get over it. And we can see that for each cluster, there's a description of the higher and lower of the different components. So that is pretty good. I think for a sports scientist, that would probably take you most of the way there. And then I asked it, can you relate these clusters back to sports and sex? And we can see that it then said, well, this is leaner individuals, higher BMI individuals, higher muscle mass individuals, relative gender distribution, more female in this one, more male athletes in this one, suggests some possible sports. Interesting, it was suggesting sports rather than just using the sports out of the data. From the looks of it, certainly from the phrasing, I would need to go back and check. But this is really great. This being able to interpret these clusters, I think, is really handy. It's the kind of thing where, you really need someone who knows about this area to go through and check that what it's saying does actually make sense. But just as a time saver, that's really great. So this has been Julius. I might try and get access to one of the upgrades. We can see the upgrades, 20, 45, and 60, a little bit less if you go on the annual, and be able to test it out a little bit more. But certainly in terms of something that's doing analysis with a reasonable degree of efficiency, and then being able to give some reasonable interpretation as well, this is probably one of the better tools that I've seen so far. So I hope this has been helpful and interesting. Certainly check it out. You get a reasonable amount of use for free. And I'll be back really soon with more videos about AI, stats, research, and random stuff.